Do you remember January 2021? One of the coldest winter spells on record for central Scotland. The country froze. Snow and ice everywhere. It was brutal. Well, my central heating packed in, and for 4 days we had no heat in our radiators. Not good at all. I think the cats kept me alive. The problem was a broken thermostat. The thermometer in the heating system failed to measure the temperature and adjust the heating accordingly. It just wasn't detecting the temperature in the house. So the boiler wasn't being activated. And we were rather cold as a result. Well, our metabolic systems in our body are controlled a bit like this, and many are constantly increased or decreased to keep our internal environment working at its optimum level. This is done using a process called negative feedback control. So let's raise the temperature and find out more. This is Think 4. Negative feedback control is the way our bodies first detect any changes in our metabolic rates. This is done in areas called receptors. The receptor then determines if the change is an increase or a decrease and sends out a message, either a chemical message, such as a hormone, or a nerve impulse. These messages go to specific areas of the body called effectors, which bring about changes that will either raise or lower the rate of the reactions. This keeps our body functioning at its optimum level and gives us a stable internal environment. The system we need to know in more detail is the control of our body temperature by a process called thermoregulation. It involves our hypothalamus in the brain, the receptor, which determines the temperature of the blood as it flows through it. A nerve impulse, the message, is then sent to the skin, which is the effector. The skin then carries out various responses to either help raise or lower our body temperature back to its normal level at 37 degrees centigrade. First, let's assume you've done a lot of exercise and your body temperature has gone up. The first thing the skin does is to vasodilate the blood vessels that lead to the skin surface. They get wider. More blood flows close to the surface and more heat is lost by radiation, lowering the blood temperature. We also sweat more. The heat radiating out of our body evaporates the water in our sweat, which also helps to cool the skin surface. These two effects combine to lower the blood temperature. The opposite happens when we get cold, but there are a few added extras. If we get too cold, our skin blood vessels vasoconstrict. They get narrower, so less blood flows close to the surface and less heat radiates out. Sweating is also reduced to an absolute minimum, so it seems we stop sweating. We also get goosebumps. This is when the muscles connected to each of our hairs contract and the hairs stand up, trapping a layer of warm air close to the skin surface and giving us lots of little bumps in our skin. Our skeletal muscles also rapidly contract and relax. We shiver. This heats our blood as it flows through the muscles. So we stay warm or we cool down and life just ticks along nicely. Negative feedback works just like a central heating system, keeping our body at a constant temperature, adjusting if it gets too hot or too cold, maintaining an internal environment so that we can survive and function normally, whether we're in a hot, humid country or here in Glasgow on a cold, frosty January morning. Talking of that, the nights are fair drawing in. I'll need to turn my thermostat up when I get home later. Keep warm. This was Think 4. Thanks for watching.